So what we have here is we've got Michael Samson from Salesforce and Rachana Doshi. And I'd like for you folks to give them your time and attention. And let's give them a round of applause. And good luck, you folks.
All right. Hi, friends. Today we're going to talk about how we can secure generative AI. Is it all an illusion, or are we really able to get clarity on the security posture of the vendors that provide these LLM services? And not just the vendor security posture, but actually the data flow, the underlying data architecture, and the systems that process all of our enterprise data. So let's find out how we can do this. My name is Rachana Doshi. I'm Director of Third-Party Security at Salesforce.
Hi, I'm Michael Samson. I'm also at Salesforce as a security engineer.
All right. So today we'll just talk about the situation as we were facing in very early 2023, late 2022. We'll perform an interactive threat modeling, so feel free to shout out your suggestions when we call for that. And we'll walk you through the security threats posed by these LLM vendors. Last but not least, we'll definitely talk about the technical controls you can implement to secure your enterprise data related to all these security threats. All right. I can't take credit for the graphic, but it's a really super interesting one to me. It took the telephone 75 years to get to 100 million users worldwide. It took the internet about 16 years to get to 100 million users worldwide. But it took, 7 years to get to 100 million users worldwide. But it took the mobile phone 16 years to get to 100 million users worldwide. But it took ChatGPT only 2 months to get to 100 million users worldwide. And so artificial intelligence, mathematical machine learning models, they're not new technologies, but what was new and unique in November 2022 was the ability to generate text and content based on a prompt. All of a sudden in January 2023, all anyone was talking about was generative AI and ChatGPT. We had CEOs who are announcing on their social media feeds how they're going to integrate generative AI all within their business products. Business teams were coming to us and innovating and saying, how can we use generative AI securely within our workflows? And the speed at which innovation was happening and the use of ideas of using generative AI in the business world were coming at us at unprecedented speed. Typically, with the slow rate of adoption of prior technologies compared to ChatGPT, think 7 years or 16 years of some of these technologies like the internet or Windows or mobile, right? It takes some years for the technology to mature and also to reach critical mass, right? And so usually with these new technologies, security is an afterthought. It's not the first point of consideration for any of the teams. But that was okay, right? In the past years, that was okay because the attack vectors, the threats, the risks that were coming out of using this technology, we security teams had time to learn the technology and then figure out what are the threats associated with it. However, as quickly as the news of generative AI adoption was coming out of the business world, us security practitioners, we were facing and looking at the bugs and the risks and the issues just as rapidly coming out of use of generative AI. At that time in early 2023, January 2023, we felt like this cartoon over here, right? We were laying down the tracks as the train was barreling down at us. We were building the plane's engine as we were flying the plane. And so for us, we had to really quickly figure out how do we secure generative AI for our enterprise? Like I said, typically security practitioners have months, years to figure out not only just how a new technology is going to work, but what are the threats and attack vectors, and then over a period of time, then build controls to protect enterprise data. For our case, and a lot of others that we talked to at the time, we had weeks, maybe months, to figure out how to secure generative AI. So some of the things that we were thinking about and questions we were asking ourselves was, how do you even assess a generative AI system? What are the things to look for? What are the risks? What are the threats? How do we create guidelines for our developers to develop against generative AI? And what are some of these key risk considerations? What are the threats that are coming at us? And so for this next portion of the talk, I'll hand it over to Michael.
Thanks. All right, so we want you to walk away with practical information. So we're going to have an interactive threat modeling exercise where we're going to ask for some audience participation. But before we do that, we have a quick primer on a couple topics. The first is on retrieval augmented generation, or RAG. Probably already familiar with this, so I won't spend too much time on it. But essentially, RAG allows you to get contextual responses out of an LLM without having to retrain or fine-tune the model. And you essentially achieve this by adding context directly to the prompt before sending on over to the LLM for inference. So here you just have a quick example on the left where you have a standard user prompt and a prompt template. On the right, you have the additional context injected in red. Now, to achieve this, you need to build out a vector database that has all of the content that you'd want to potentially include as context around, as well as the embeddings for that content. And you generally generate the embeddings using an embedding model, and it's essentially just a numerical representation vector format of that data. And then along with all of that, you'll store any metadata you want on that content, such as where you sourced it from. Once you have the repository built out, as you're processing prompts, you'll generate embeddings for those prompts, query the vector database for the most similar matches, and then you take the top X number of matches and send them over along with the prompt to the LLM. Now, the second item is around LLM plugins or tools. These are essentially just function calls, often Python functions. And so the way you utilize these is that you basically tell the LLM the functions or tools that are available to it, along with some instructions on the arguments that are required and examples on how to invoke that function. Then when you get the output back, you parse the output for any invocation attempts. And if there are any, go ahead and call the function with the supplied arguments. So now we have the threat modeling exercise. So I'm going to explain what's going on in this diagram here, and then I am going to open it up to all of you to kind of throw out what you see potentially going wrong here. So here we have an organization that's built an internal web app to provide AI chat assistant functionality for their staff. The web app runs in AWS. They've implemented RAG with various internal resources. They have a plugin environment where they're executing the tools that they're making available to the LLM. In this scenario, we could say that the tools that are being made available are a Python interpreter and a database query engine to query a database that has a table with various metrics. And you could use that to pull flow log data. So for example, someone in IT could ask their chat assistant how much traffic has XYZ website received today, and the assistant would be able to respond with that. Now, this organization is not hosting their own LLM. They're utilizing a third-party LLM service provider that allows you to utilize their models via API call. And so here we have the LLM service provider's environment. We'll say that they're also running in AWS, using AWS SageMaker to build and run their models. As they receive a prompt, they'll run some supporting models against it to identify many things such as acceptable use policy violations or anything of the sort. If they're going to go ahead and process the prompt, they'll go ahead and run inference against their model to generate a completion and return that completion back to the calling system. They'll also go ahead and store a copy of the prompts that they've received and completions they've generated in a persistent data store, and then use that data store to run any usage audits, as well as use it as a training data source for future model updates. And so with that, I will pause. So feel free to kind of yell out any potential threats or risks that you see. Yep, I see a hand raised right there. Yeah, that's definitely one of the threats. Oh yeah, sorry. The threat was basically an internal actor could achieve basically arbitrary code execution through prompt injection in the plugin environment. And having unrestricted arbitrary code execution is definitely a red flag. Yeah.
Maybe sending your contacts into a third-party LLM. I mean, trace it all the way to provider's app.
Yeah, there's definitely the concern of how that service provider is utilizing the data that you send in, and also whether or not the service provider is trustworthy. But yeah, the context that you send in is definitely a concern and how it's being used. Yep.
What are the data retention policies of the third party?
Yeah, what are
Corporate data retention policies in there might be?
yeah, the data retention policies. Yeah, so that's definitely another risk. As far as they could be storing it forever, and yeah, the use cases for that data are questionable. Yeah. Yeah, so the item was want to ensure there's proper standardization and SQL statements, and yeah, that's definitely one of the threats. You want to ensure that you're properly sanitizing and using parameters for everything you're receiving from the users, but you also want to do that for everything you're receiving out from the LLM. So you want to treat that as yet another untrusted data source. Yeah.
Indirect prompt injection via the internal resources. So any kind of third-party actors can get to the internal resources, data exflow, efficient, etc. on the end user.
Yeah. So indirect prompt injection through the internal resources. So that's yet another threat. And so you do want to ensure that you are sanitizing everything that you're pulling in to that data source, and you want to make sure you're curating the data into the internal resource that you're utilizing. We are missing padlocks. Yeah. I'll take one more and then.
Authenticating the API gateway, so
Yeah.
Can you repeat
Yeah.
that?
Sorry. Yeah. Yeah. So authentication, so that only authorized internal users can call the app. Yep. So that's yet another threat. So you want to make sure that you have proper authentication and authorization controls at the API gateway. All right. So. Yeah, so that was great. You guys called out a lot of them. So I'm going to go ahead and run through a few. So the first and probably most obvious is potential compromise of the service provider's environment. This can result in exfiltration of all of the persistent data, and depending on the foothold of the threat actor, that could also result in exfiltration of prompts as they're being submitted. Again, depending on the foothold of the threat actor, it could also result in tampering of the completions you receive back, either on the fly as they're being returned to the calling system, or by tampering with the service provider's training data set. Then you have the risks around how the persistent data is being used. So utilizing that persistent data for internal audits essentially makes your data available to a much broader audience than it typically would be compared to customer data hosted by an enterprise SaaS solution. And then utilizing that data for training of future model updates can result in your proprietary data being returned to unauthorized external parties in the form of completions. And then there's potential over-reliance on LLM output. So LLMs are known to hallucinate, and the responses you receive could be outside of the parameters of what you're expecting. So you wouldn't want to automatically invoke any sensitive actions based on an LLM output. And then you have the plugin environment where you're executing arbitrary code, which can result in compromise of the underlying system, access to unauthorized resources that you don't want your internal users calling, and then contamination across users for the execution environment. And then prompt injection, pretty obvious one. If there are any secrets that are included as part of the prompt template or a context through prompt injection, for example, you could have the LLM reflect that data back to you in the form of a completion. And then authorization bypass. So you'll want to ensure that your RAG data source is enforcing the authorization policies of your data sources, so the source system. Same with your plugin that is executing queries for on external databases. You want to either perform that in the context of the user. If you're executing those in an elevated system context or service account context, you could end up returning data that you didn't want queried. And then encoding failure, you want to remember that this is still a web app and the general web app vulnerabilities still apply. And the LLM output should be treated as untrusted data, so you'll want to make sure that you're encoding the output before rendering, just to ensure you're not running into unintended code execution in the browser. And then there's also availability issues. So if the service provider runs into a system outage, or if there's resource exhaustion, this could interrupt any critical business processes that you have relying on the web application. So this table is just what we already discussed. It's mostly there for those that don't have the benefit of a live presentation, so I'm going to skip over those and pass it back to Rachana.
All right, thank you all for the participation. That was great. So as we were threat modeling and building our assessment methodology, we kept thinking about what are some of the key considerations we should have for scoping the risk of these generative AI systems or LLM vendors, right? And so one word of caution, if you will, right? Keep in mind every use case is different, and you have to consider your enterprise's unique use case, your enterprise context, as well as the risk appetite within your enterprise. So the first consideration we want to have is what of your enterprise data is being processed, stored, transmitted by this LLM provider? What is the sensitivity of the data that is being shared with the vendor? What will be the impact to your business if this data is leaked, hacked, or published in the New York Times tomorrow? You'll also want to consider where is this technology being hosted, or who's responsible for the security of both the application itself, but also the underlying infrastructure. So obviously, when you think about something like a supplier-hosted system, then all of the risks around web applications come into play. But if you're thinking about hybrid, then you need to consider the shared responsibility model, where the supplier or the vendor is responsible for the security of the infrastructure, but then you are responsible for the secure configuration of the application or the LLM itself. And then if you're completely hosting this all on-prem, then you need to think about not only just the application security, but also the underlying infrastructure. Also to consider, the next two things to consider are around the type of technology that you're procuring. So think about, what kind of a model are you getting? So generative AI models, generally speaking, are really good at output based on an input. So they're producing, text, image, videos, audio, all kinds of stuff. Versus large language models are primarily outputting something large text. And then there's other kinds of models that are really good for code generation or classification, grouping of data and such. We also look at the types of services that these models are providing to us. So like the example says, there's so many models now that produce text, video, code generation is particularly new and interesting use, videos, audios. And so there's a lot of security concerns around just the kind of content that's being generated, but also think about the privacy and the ethical considerations behind some of the output that's being produced. One key concern or key thing to consider is how these models are being integrated within your environment. So if you are using the models for automated workflows, as an example, you're going to publish automatically an article or something based on a prompt, or if you're going to generate code that will automatically get executed in your environment, those are particularly risky or problematic from our perspective. And then last but not least is the type of relationship you have with your vendor. So third-party vendors, which is typically the vendors you have a contract with, where you can enforce your security requirements, you can have contractual obligations that the vendor has to meet, and obviously subject themselves to your security audits and reviews. Fourth-party relationships are where you don't have a direct relationship with the vendor themselves. What we are seeing is there's a lot of vendors who are integrating generative AI within their services and offering it to you. And so even if you're not directly procuring a generative AI provider, you already have most likely a generative AI system within your environment that is processing your enterprise data. And so in that case, you need to consider the kinds of questions you're going to ask your third-party vendor. How are they securing your data in this fourth-party generative AI vendor's environment? What kind of security assurance are they doing on their third parties? And so, again, the type of relationship with your vendor matters. Now, really, let's get into the meat of it, right? The technical controls are some of the controls you can actually implement to mitigate the threats or the risks we just talked about. One of the first ones is independent verification. Now, not a true traditional technical control, but we find that this is really a good proxy for telling us how mature the vendor is or what their security posture is. So we typically look for independent web application pen tests, ISO certifications, SOC 2 Type 2 audits. These auditors are spending months doing invasive reviews of the vendor's IT and security practices. These are things that we definitely cannot spend time on with our vendors. And so we look at those to really understand how deep the auditor went, but also, the vendor's maturity within their security practices. Encryption, again, a basic security control, but one that we found really important as we were evaluating generative AI systems ourselves. Making sure that all of your traffic, all of your data is encrypted, not just end-to-end, but at every node in this workflow that you see, right, throughout the life cycle. Making sure that your prompts and completions, your inferences are only unencrypted for short periods of time while they're being processed and then re-encrypted before it's transferred to the next step in the workflow. That becomes really critical, especially, with this emerging technology where you just don't know what some of the threats or attack vectors are. Okay. Zero data retention and zero training. Very early on, we realized that this was a key control that we wanted out of our generative AI systems and vendors. So zero data retention, what that means is making sure that you have the option with your vendor to not have them store any of your data, whether it's prompt, inference, completion, or even log data. So what that means is that on your side of this diagram here, you have to implement some key controls. You have to look for things like abuse detection. You have to look for monitoring of, the prompts and completions. If there's an issue, the prompts might get dropped, and so you have to be prepared to resend the prompts back, because again, in this scenario, the vendor is really not storing any of your data anywhere. It's just in memory for a transitory time, and then it's going to process it and bring it back. So if there's any issues there, again, it's going to be more on your side. Similarly with zero training, right? So making sure that none of your enterprise proprietary intellectual property data is being actually used for training the model itself. Like we talked, right? When you train the model with this data, it can inadvertently leak, to the public, and so we want to avoid that. Data masking. Again, one of your, what you would call standard security controls, but again, important here in the context of GenAI. So data masking means you are either obfuscating or replacing or doing something with, or not even sending, in some cases, what we would call sensitive data. So it could be personally identifiable information or PII. It could be your intellectual property. It could be secrets. It could be any kind of sensitive data that you don't want to leave your boundaries. And so in this case, before you're actually sending the prompts, you're scrubbing the prompts for any kind of sensitive information. And then when the completion comes back, you rehydrate that same prompt, the response back with the sensitive information, and you serve it up back to the user in the UI. And then for them, it's a seamless experience, but this way you have really minimized the risk of your data getting exposed. Michael will talk about the next.
All right, so human validation, that's an obvious one. So if you are going to use LLM output for any sensitive workflows, make sure there is some sort of human validation in that workflow. Input standardization and parameterization, as we kind of discussed earlier, you want to treat the LLM output as untrusted data. So you want to ensure that you are properly sanitizing the input that you're sending over to your functions, and also for any queries utilizing parameters to avoid any sort of SQLi type of vulnerability. And when you have arbitrary code execution, you want to make sure that you are utilizing some proper isolation. So have network filters in place, ensure you're spinning up a unique execution environment, either through a container, either for each invocation attempt or for each user session. And then if you are managing the underlying host, you'll want to make sure that there's proper kernel level isolation between the containers. So using something like Firecracker or gvisor. And then to mitigate against prompt injection, jailbreaks, things of that nature, you'll want to utilize models to kind of assess that input and output that you're processing. Now, there are commercial solutions that have come out to provide kind of like a WAF type of solution for your AI solutions. However, there are some open source options available. So, for example, there's NVIDIA's NeMo guardrails that essentially acts as a wrapper for your generation attempts. So essentially you can define guardrails that you want implemented for your input and output, and then you essentially call NeMo guardrails for the generation, and it'll automatically apply that configuration for everything that it's processing. Then there's also LLM guard. So this one acts a little differently. Here you're essentially invoking a scanner. You can have scanners of different types. And then you pass your prompts and output or completions through those scanners to identify anything that's outside of your the parameters that you've created. So whether it's like toxicity or ensuring that all the usage remains within a particular use case. Now, with LLM Guard, for a lot of these, it'll utilize open source models that'll pull down from Hugging Face. NeMo Guardrails is more so utilizing the LLM service provider that you're actually using. So it's just utilizing custom prompts to have your LLM analyze it to see if it meets whatever your guardrail is looking for. And then authorization controls. So there aren't a lot of great solutions for RAG vector databases to enforce granular access controls. So generally you'll want to try to go for utilizing data stores or data sources that your entire user base should have access to, or slots of like departments or so. And you can use like metadata filtering to filter for those when you're utilizing your vector database. However, if you try to apply very granular controls, you run the risk of your data sources and your database authorization controls going out of sync. So that's the main risk there. And then for your plugins that are calling external resources, if they're calling non-public resources, you'll typically want to utilize your user's context whenever possible. So essentially utilizing OAuth to ensure that you're still enforcing the authorization controls of that target system. And then this is still a web app, so your typical secure software development lifecycle practices still apply. So it's just a reminder of, don't forget those basics. And then you'll want to ensure that there is some sort of high availability configuration in place if your application is supporting a critical business process. Another option is to also have a backup service provider you can utilize for AI calls. Since it is consumption-based, it might not add too much cost, but you may be calling a different model, and there's the added overhead of the additional code base that you have to maintain. And then these are the items we discussed. These are the Git repos for LLM Guard and Nemo guardrails if someone wanted to take a picture of those. All right, so what can be tested? So since these AI-enabled applications are typically web apps, your web app pen testing processes still apply. You'll want to also look for any sort of information disclosure, so any sort of secrets that are included as part of a system prompt or part of the general prompt template that you can get reflected back to, and to look for any sensitive data that may have been included as part of the training data that you can get the LLM to return to you as part of the completion. If you're unfamiliar with prompt injection, Lycurus Gandalf is a fun way to kind of get acquainted with prompt injection. Then you have vulnerable integrations and plugins. This adds a pretty interesting attack surface. So if you have systems that you're auditing or testing that have various plugins, you'll want to spend a fair amount of time on these, especially if there's anything like a Gmail plugin or something like that where you're pulling a user's email for processing into the application, because then you're involving yet another untrusted data source into your system. And then you'll also want to test for the effectiveness of the various guardrails that you would have implemented. And so there are also various SaaS solutions out there that are starting to include AI functions within their application. And so you'll want to make sure you have agreements in place with them to make sure that they're not going to utilize your data to train public models that they're going to make available to other customers. And you'll want to go through the similar threat modeling exercise with those solutions to identify any potential risks there. If your third party is utilizing a fourth party to you, like GenAI provider, that makes it a little more tricky to audit the whole thing. But you'll essentially want to make sure your third party is going through the same due diligence process you would go through. And you'll want to scope the assessment to the risk factors of your particular use case. And so there's just reinforcing that what we kind of went over still applies, whether it's an internal application and third-party LLM service provider, or a third-party AI-enabled application and a fourth-party LLM provider, or if it's a third-party AI solution provider that's training their own models. Now, it's not all doom and gloom. There's also ways that you can utilize LLMs to make your life easier. These are a few projects just to call out that can help you leverage AI. The first one is Data Concierge AI. Essentially, is a project that implements a local RAG framework for you. And utilizes local open source models. So essentially, you would have a local AI chat assistant with your data never leaving your system. TAC AI is an AI-enabled threat modeling project. So it'll essentially take your system design as input as YAML, and from there it'll generate data flow diagrams, potential mitigations, potential threats, and potential mitigations for those threats. And then Microsoft AutoGen is a framework for creating AI agents. And so you can use this framework to help you build out agents to perform initial triage on SIM alerts, or assist with initial triage on security support requests or questions. And so for the lessons learned, the big thing is don't forget the basics. It's very easy to get pulled into the new and shiny bits and forget about the fundamentals that should be in place. You'll want to, as you're assessing these AI systems, run through the data flow diagrams and system architectures. A lot of the components that are in play are components that you're already familiar with. And so as you go through that exercise, you'll quickly start to identify potential threats for your use case. And your use case may have the same threats that we discussed here today, fewer threats, more threats. You'll want to scope it appropriately. And as with any technical risk, as you're communicating technical risk to your business partners, you want to make sure that you're translating that into business risk. And then you'll want to partner with your business partners to enable them to innovate securely instead of kind of waiting for them to come up with solutions that you may just nix on site. You want to, it's typically a better relationship if you get in early and help them find a secure solution. And risk acceptance is always an option. However, if you're going down that path, you'll just want to make sure you understand the risk and that your business partners understand the risk. And is there anything you don't got there?
I'll just add or reinforce that for us getting early on, just starting with basic controls like authorization, authentication, encryption really helped us get a foothold into even understanding the GenAI systems. But also really we spent a lot of time, a tremendous amount of time just walking through the data flow diagram, the data architecture, and walking through how our data will be processed by the GenAI system at every single node, and then looking at the security controls at every single node to say at this point, is this data encrypted? And who has access? And what's happening with it? That was really critical for us to really then get to the true threats of the GenAI models, or the systems, but also what kind of controls can we implement in partnership with the business to enable them.
That's about it. There are some additional resources, like we'll publish these slides somewhere. But if you want more info on some of the threats that we discussed, you'll be able to find that here. These resources also have more threats that we just couldn't get through just because of limited time. And with that, thank you. Thank you for attending this session. So this particular image generation model had some trouble spelling thank you. So it worked on another attempt, so thank you. And then with that, we'll open up for questions. So the generation model also couldn't spell out question or questions, so we want Q&A.
You actually got a couple questions. One that came from We Are Anonymous, so definitely a take on Anonymous. With vendors, is exclusion of your company's data from storage, training, is that typically an admin control setting, or does it require custom contract language?
Do you want to go?
It's actually both. So with our vendors, we made sure it's part of the contract language. But before you can get to that contract language, we actually had to work with the vendor and the business to make sure that it's actually feasible, right? The business use case doesn't require the actual context or the prompt to be stored or the responses to be stored to serve up further prompts. So that was step one. And then the next step was then to figure out for the vendors, especially early on in January, February of 2023, nobody knew what was zero data retention. And so both our engineering teams and their engineering teams and security teams had to work together to figure out, okay, what do we do? And then how can they process the prompts and return back without any kind of storage? And so there was some architectural discussion there. And then the last piece over there was, how do we, as their customer, the vendor's customer, ensure that zero data is actually turned on? And so typically, as far as what we've seen right now, it's not a configuration that we can turn on or off. It's something that the vendor turns on or off, but we have visibility in our admin dashboards to actually see when it's turned on.
Okay, thank you. Another question? And if you folks have any other questions, please go ahead and throw them into the system here. Have you done work around creating frameworks for developers, integrating LLMs into product code? And do you monitor or track usage?
Not specifically our team, but we have a partner team in product security that has actually worked on a framework. Well, it's not specifically a framework, but definitely we have guidance on how our internal teams can develop against generative AI. yeah, we have a product team that's looked at it. It follows some of the similar things, your SDLC best practices, secure coding best practices, web app best practices, and then you throw in some of these, new ideas. But yeah, we haven't done it particularly, but our partner teams have.
Okay, well, thank you. We've got a couple of gifts for you, both of you. This one's for you, Rachana, and we have something for you, Michael. And this is care of Socket Security. So our friends at Socket Security have been gracious enough to sponsor these gifts to our presenters. Thank you both very much. Thank you, folks, for coming.